Determine if the relation is 1 to 1, meaning for every x there is only one y, and for every y there is only one x. And does it have an inverse? In our first relation, we have the domain of Phil, John, Scott, and Jake, and the range of Elizabeth, Eileen, and Nancy. In order for this to be a 1-to-1 relation, for every variable in the domain, there must be only one variable in the range. First, we check the domain. We have Phil to Elizabeth, John to Eileen, Scott to Nancy, and Jake to Nancy. Since every variable in the domain goes to only one variable in the range, then we have completed the first half of the criteria for a 1-to-1 function. But now we must check the range half. We have Elizabeth to Phil, Eileen to John, Nancy to Scott, and Nancy to Jake. Since Nancy goes to both Scott and Jake, this cannot be a 1-to-1 function, since for the y there are more than one x, or for the range there is more than one domain. It cannot be an inverse, because in order for something to be an inverse, it must be a 1-to-1 function. So therefore it cannot have an inverse. In our second example, on a graph, the same thing. For every x there must be only one y, and for every y only one x. We can determine this with simple horizontal and vertical line tests. In our vertical line test, shown in red, we can see that no matter where you put the vertical line, it will only cross the graph at one point, meaning for every x there is only one y. So then we check the horizontal line test, but it crosses the graph at 2 points, meaning for every y there are 2 x's. Therefore, this cannot pass the horizontal line test, and therefore it is not a 1-to-1 function. A 1-to-1 function must pass both the vertical and horizontal line tests. Since this is not a 1-to-1 function, it does not have an inverse, because in order to have an inverse, a function must be 1-to-1.